Mr. Cesar Belloso will take the floor. Good afternoon. Thank you, Pablo. Thank you, folks, for your time. The global challenge of climate change is something that we as growers know is something local as well. We are concerned with both mitigating climate change. That's why we adopt no-till practices in order to capture carbon. This is part of our essence. That is why it is important to have the view of Jeff Cruz in considering all the work that he did on models that can contribute to change the land use and water management at the groundwater level. This panel will give us the possibility, with the presentation of Pablo Biacertua, how the national government is working on this topic with a federal approach in order to adapt to climate change. So we will start with the first presentation, with Pablo's presentation. Any questions you have, please use your phones, and you can ask questions through WhatsApp or SMS. Good afternoon, everybody. Thank you very much, Cesar, for your introduction. It's a pleasure and an honor for me to be here in Brazil, sharing this panel with you, who's an Dutch expert. One of the priorities the national government has is the smart insertion of Argentina in the world. We believe that Argentina has more to win than to lose in this intent of being part of the world. And I think that our relationship with the Netherlands is part of this insertion we are looking for. I want to share with you a brief first part of this presentation, what things we see regarding adapting to climate change. First, I would like to say that climate change is for Argentina is far more important than the perception is, for two reasons. One, because we are not a very large, we don't are very large emitter. We don't have much greenhouse gases emissions. Agriculture is closely related to climate, and the climate variety or variability is increasing. For instance, the tide going down, the low tidal movement in the Paraná River. This change in tides should happen not so frequently. It is happening very frequently. I would like to make a presentation regarding our national water plan. We have set two objectives. One is to improve the quality of life of Argentinians, and the second one is to generate employment, to create jobs. And all these two things happen in the farming sector. So this is a huge opportunity to improve life quality and to create employments. A strategic pillar is the drinkable and purified water and sanitation. Is drinkable water and sanitation. We have a deficit in infrastructure, and we are impacted by extreme weathers, and also with a problem of water scarcity to supply the cities. But we have another pillar, which is adaptation to climate extremes. And the third pillar is water for production. These two pillars go hand in hand. And this fourth pillar has to do with infrastructure. That is the dams and the water ducts that Argentina has to build to adapt to the climate. So we need to be certain, and we need to be able to make decisions at different weather scenarios. These four pillars imply a significant investment. The government has hired works for more than 250,000 million pesos. The question is where to invest and how to invest. These are the 17 goals that have been set by United Nations for Sustainable Development. And we have incorporated these goals in our projects. The first thing that I want is to share with you the main adaptation work that we are doing. This is a very important work site. This is San Antonio Canal. This canal goes along the borderline of Córdoba and Santa Fe. This is 880 kilometers, 180 kilometers long canal. We are doing this because we expect to have an impact on 500,000 hectares in order to be protected from climate variability or weather variability. This work has been started 2 years ago, and we have some more months ahead before it's completed. This is another work we are completing. This is the Río Salado master plan. We have hired 220 kilometers that gets us far. It starts in General Belgrano, and it will reach past Bragado. We have invested $1.2 billion. This is the largest investments that have been done so far. It's 3 times more investment than what has been done until 2015. These are some of the pictures. We have called for a bid to build a canal in the northern part of Santa Fe, where we have many dairy farms. This is being funded by the national government. The budget is about 400 million pesos. We did something that's very important regarding strategies. Apart from the works themselves, we need other components. One is data, information, having data available in order to develop policies, including alert systems in case of flooding, and also alerts that have to do with adaptation, with crop selection, or land use, or financial derivatives, different type of insurances. Today, Argentina has a waterway network of 420 points that are not used in real time. We have hired and already implemented the renewal of that network. We have scaled it up to 600 points all of them in real time. We will have information not only about the volume of water, but also the quality of the water, not only quantity, but also quality. And this will help us put in place adaptation policies 4.0, so we can use the big data and we can use artificial intelligence. Comparison is, Argentina does not compare very well to the rest of the world. Even when we complete this investment, our territory is 1/3 of the territory of US. They have about 45,000 points in real time to cover their territory, but Argentina will have 600 points only. So there is a great, it's a great challenge, the fact that we need to complete these works and then to start to gather data. The second point is the system governance. What are the decisions that will enable us to have all this system in place? These are works that have been complete or that are being completed in the central area in Argentina. This is the San Antonio Canal. This is in Córdoba, San Antonio. This makes the water flow in the north-southeast direction. Here we are completing some works in the Picasa Basin. We have completed we are building the reservoir number 3. This is the Salado River. It was built only up to this point. Now this work has been extended. We have driven the La Picasa Basin outflow to the Paraná. This area does not have natural drainage, so we have to understand that this system needs these works, but also many more works. And we also need data, and we need capacity from the government in order to achieve what we need. This is a summary of one of the main projects that we are completing. I probably would need more time, but I want to show you the continental waterway. This is a project that we are about to start. The idea is to build a waterway that starts in Belleville as far as Catriló. This is the final project, the way the project will be completed. This will help mitigate climate change and will speed up transportation. We are working in collaboration with the Netherlands. There are some Dutch institutions that are participating in this project. This was a result of the visit of President Macri, the visit of President Macri to Holland, to the Netherlands. This is the first time an Argentine president visits the Netherlands. The idea is to capture the surface water, especially in the Rio Quinto, that has not, that it flows in an extended area. The idea is to capture the water flowing in this river along 650 kilometers. If we capture this water, we would reduce the flooding peaks and so that the dwelling time of the water in the lowlands would be reduced significantly. That water available along these 650 kilometers can be used for irrigation. So it is enough to irrigate 600 or 605,000 hectares. So we here here would have the possibility to create a tool to regulate and impact and reduce the impact of flooding, and at the same time, it will give the possibility to, it can be used as an irrigation means in areas that are affected by drought. Most of our production is transported along the Paraná River, and this waterway is parallel to the Paraná River. The lack of rainfall in Brazil and the tide going down in the Paraná River means that more than 65 vessels couldn't take the cargo, couldn't load the cargo in the Paraná River. We cannot say that the draft of we cannot make sure that this waterway can have a draft of 40 feet. This is what is needed for the big vessels. Today, the main 15 ports of the Paraná waterway are really jammed, but on the land, not in the water. And that jamming of traffic brings about complications. So this system has been thought only for climate adaptation, but it has a fringe benefit, that is, it could contribute to improved transportation. We've seen a similar case in the Netherlands, Venlo. It is the dried port in Rotterdam. And so we imagine or we are making the comparison, and Catriló would become Catrivenlo, because it would be a park that would provide a multimodal transportation means. Of course, we would need trains also, but if this system existed here, we already could give, we could fund this, we could provide money or funding incentives so that we relieve the congestion or the jamming that we have in the Paraná River ports. I know that this requires more time to make a complete presentation, but I just wanted to show you an example of what are the challenges that we will have to face in the future. This will provide us a solution in the mid and long term, and it will also help us provide a territorial and regional development in Argentina.
This is the two different waterways, and we should remember that the first reason why, if we get to approve the continental waterway, has to do with a positive impact regarding climate, but it's designed in such a way that it will also be the right means for transportation. And these are some of the main crossing points of this waterway. You will probably know these. These are from the Netherlands, and these are some of our own crossing points. Finally, well, I talked about projects, data and policies, and government capabilities. And these are the basin committees. So finally, I like to say that it is key that Argentina must adopt these committees. What we have done so far was to create these basin committees that are about 16 million hectares. This compares to several European countries. So we have said that we should not invest in projects prior to the approval of these committees that are made up of governors, basically, and their ministers in their executive committees. So the nation does not have any law, but it is a discipline we need to create, we want to create based on the experience we have, based on the fact that unilateral decisions have failed. So these committees, we have sent two of these to the Parliament, to the Congress, so that national laws can be passed. So they can have a legal person once they are passed. Anyway, this is just a first preliminary strategy, and we are aware that this requires further development in order to become effective, so that changes can actually occur in terms of land use, in terms of how these systems are managed, and also in terms of what kinds of proposals, such as the waterways, could actually work in Argentina. So I'd like to end with this statement: with intelligence between the environment and economy and development, we must think of a way to develop infrastructure in the long term. This means adapting and concerning the large impact that adaptation will actually have. Thank you. Thank you, Paulo.
Hola. Okay. Hola. Muchas gracias por la invitación.
Thank you for the invitation, but I will give the presentation in English. I can speak some Spanish, but I'd rather shift into English.
Having said that, I will show one picture to start with, and that one could not be translated, so sorry, it's in English, but I will explain a little bit, because I came here with the idea that you have flooding issues and things were too wet, but then talking to the people here in Argentina, I realized and looked at the newspapers that this has been a terrible year for farming people. Worst drought, it says, in 30 years. And Argentina farmers slammed by the worst drought. And on top of that drought, you had an issue with heavy rains, which complicated harvest. Well, I could not help making a parallel to what happens in the Netherlands. This summer, just a few days ago, I made these pictures and copied them from a Dutch newspaper. We had the drought in the Netherlands. Worst drought since ever. So newspapers are hit by many articles about how to deal with this drought. Large damages occurred, and arable farmers, that's the last remark, are asked the Dutch government for assistance to help them in drought. Well, my talk will be about, and I hope it is not too technical, but it will be about methods we use to deal with too dry, too wet, and too saline conditions in soils. Because I will basically speak about what happens in soils. And it's part of what I can tell you is a result from a very nice cooperation I had within a few projects between Argentina and the Netherlands. And this cooperation dealt with an analysis, an agro-hydrological analysis of groundwater and land use in the pampas of Argentina. Well, this cooperation started a few years ago within a European project. And that was a project framed within a so-called GEO-GLAM. Some of you may be familiar with it. That has to do with global actions to improve crop monitoring and crop yields and increase and maintain high crop yields. So INTA was our partner here in Argentina, and INTA participated in the European project and also participated because they maintained part of a global network of observations. Parallel to that, I was also participating in a Dutch project, Water Vision it is called, and that deals with hydrological measures on agricultural yield. So for instance, if in the Netherlands a drinking water company subtracts water, groundwater will go down, and then the farmers complain, of course, because they have less yields, they get yield loss, and these losses are then compensated by institutions, by the government basically, or by the drinking water authorities. And the quantification of these losses in euros is determined by methods which we developed together with Dutch water governance. Well, within this project, I was a team leader of a part which dealt with the environmental impact assessment at different scales, ranging from field scale to regional scale. And we did that in many parts of the world, but I will of course limit myself to what we did in Argentina. We started actually with an analysis of nitrogen content of soybean, because that was the first question here from the Argentina group. And we set up our tools to be able to do that, but gradually we shifted our goal to the impact of land use on groundwater, because we discussed it and that seemed at that time a bigger issue. So we set up a monitoring framework, and then monitoring to our perspective is a combination of observations, modeling, followed by measurements, and that framework is actually a kind of a cycle which is illustrated in this picture and which I will try to go through within the coming 10 minutes. So it starts at the top using physically based models as best as you can get, and that's how we started. I briefly explain this physically based modeling. We have in Wageningen a long history of building models, and two of them are very well known. One is for soil hydrology, and the other one is for crop growth modeling. Some may know the soil hydrological, it used to be called SWOTEREN, it's now SWOP, but the other one is BOFOST, it's for World Food Studies. Both have a history of more than 40 years, and we coupled these two models to be able to model this in a dynamic way. And in between, we extended the crop part which has default the carbon, dry matter increase and things like that are being modeled, but we extended it with nitrogen amounts in the crop. Especially for soybean, we thought it was necessary to deal with nitrogen distribution in the crop. And we wanted to be able to relate this nitrogen in the crop with nitrogen in the soil. And therefore we put cycles in between to deal with the carbon and nitrogen cycle in the soil, this part, which then I'll show you just briefly how these cycles in the soil are implemented. We have the carbon cycle in the soil, based on a well-known ROTC model for those who are a bit familiar with this. And it's based on different pools of organic matter which are decomposed, and then during the decomposition process, nitrogen is released. This nitrogen then goes into a nitrogen pool and is then transformed into ammonium and nitrate. And we wanted also to be able to predict leaching of nitrate. So that is why we put these modules in between. Well, after having done that, we went to testing at field scale, very important stage. We did it at the national scale of the Netherlands and looked for field observations where not only crop yields and crop growth was modeled, but also soil hydrology. Because if you, being a soil hydrologist, if you want to be able to predict water balances of the soil, you have to be able to deal with actual yields. And with those we wanted to get from field observations also. Well, and preferably long-term observations. We use different crops, grassland, maize and potatoes. After having done this for the Netherlands, together with the Dutch water governance, we then said, okay, now it's acceptable. We will use it in the Netherlands. And actually, a few weeks ago, I had a user meeting, and this type of method is now used by Dutch governmental institutes all over the Netherlands for different purposes. Well, we then said, okay, for the Netherlands, let's now also apply it in Argentina. But do a first field test with Argentina data. Well, with the assistance, of course, from the group of INTA, we got access to a lot of field data. I will skip the details. We had, our focus was on soybean, so we got field experimental data from different fields in Argentina, and we made comparisons, like you see one example here on the picture, which shows the observed values as dots, and the lines are the simulated potential and actual yields. Well, these kind of results, we thought, okay, acceptable for soybean, but we also want to look at other types of land use, so let's also look at wheat and maize, and not only for 1 or 2 years, but preferably for a long time series. So we got and I must say we were very enthusiastic about the accessibility of Argentina data, especially the crop data and the climate data. So we were able to simulate a long-term series with yield estimates from regional statistics. And while these kind of results, not go into detail, but it gave us the indication that, okay, we're satisfied. We can now move on to a first next step, which was look into detail how did we model the partitioning of carbon and nitrogen in the crop. We had these field experiments, thought it was accepted, but now let's do some additional experiments for the partitioning of carbon and nitrogen within the crop. And we got also therefore assistance from people in Rosario to analyze field experiments where they had a focus on irrigation. So they had observations of very dry conditions, which we then also simulated. And at this way we got impressions of and accepted our monitoring tools. So we were ready for the next step, and that was actually an application at a regional scale. Usually that is at least consists of 2 components, data analysis and spatial units. Due to a lack of time, I'll save you the details, but we used all kind of maps. This is a global map collected in Wageningen by the ISRIC Institute, who collected in years before Argentina soil data. So that was one map. Another map was, of course, weather data you need. And then we collected these data, merged them, put them in a so-called GIS system, and with this tool we analyzed about 40 million hectares, so about 3/4 of the pampas we analyzed, and we simulated a period of 27 years. Well, and then we analyzed our data, of course. This picture shows you on top the variation in time. So we started in 1998 and simulated until 2015, and each box plot, they are called, shows the variation in space. So picture gave us an even indication that you have a huge variation only in precipitation already, this is, and it shows variation between a few hundred millimeters and almost up to 2,000 millimeters of rainfall per year. At the bottom, the two slides show you the spatial distribution of rainfall. On the left-hand side in 2008 and in the right-hand side 2012. So obviously wet years, much higher precipitation. We then said, okay, now we can go and do our regional analysis. And we focused on, our first indication is, do we have realistic yields of soybean? Okay, we looked at results for the whole long time series, compared it with other studies, lots of studies by very good studies by Argentina researchers. We compared it and found our actual yields satisfying. So we then switched and looked at other things which had our focus. So we switched to the groundwater recharge, because that was one of the things we wanted to focus on. And this is then the groundwater recharged on the left-hand side for 2008 and on the right-hand side for 2012. So it's a dry and a wet year. But in a wet year, of course, you have more groundwater recharged. And this is then a situation where groundwater is very deep, so deeper than 5 meters. So there is hardly no influence of the groundwater to the crop. Generally, roots do not get that deep. But we were also interested in looking at what if groundwater increases, what does it do to the rooting and to the capillary rise and the upward flux. Well, in the left hand, so we simulated 5 different situations, plotted here. The first one is with very deep groundwater, and then we increased our groundwater with 1 meter. And we did that for the whole of the pampas. Well, then this picture shows you on the x-axis, on the y-axis, the vertical upward flow, water flow to the root zone in millimeters during the cropping season. And on the x-axis, you have the groundwater table increasing from -6 to -1 meter. And what you see that even if you have very deep groundwater, you still have an upward flow. But this upward flow increases as groundwater level increases. Okay, of course, and you can plot that also that's what we did on the right-hand side. We plotted on the x-axis the upward flux to the root zone again, and on the y-axis the yield. Well, there is of course a good relation between rising groundwater and the upward yield. Well, that was one of the things we looked at. There are a lot of things more we looked at. For instance, at downward nitrate leaching, because that is another topic. We compared that with a case where we introduced crop rotations. For the pampas as a whole, the nitrate concentrations are very low, but we observed locally high values, as we also found in literature in some cases. So increase of nitrate leaching may occur, especially if you go to crop rotations where you have to apply high doses of fertilizer. Another thing we looked at is salinity in groundwater. We only did that for soybean, and we did not see much impact. But that, I think, is not very representative, because you have to look also at other types of land use, which will be more influenced by high groundwater. Soil structure was another item we looked at. So physical data is hard to find. We put a lot of money, and together with INTA, we were able to use soil physical data from Argentina, which is very nice, I think, because this is a crucial step in determining the partition of the precipitation excess. Does it go into the soil, or does it go via runoff into the surface water and causes flooding maybe? Or, well, another thing we looked at is platy structures in the soil, which occur frequently and have a large impact on rooting depth and yield. Well, having done all this, I now skip, also due to time, to some conclusions and results we draw from this study. Rising groundwater, as shown, has a strong impact on agricultural production. Does not only have to be negative, because capillary rise may cause an increase of yields, but it has a large spatial and temporal difference. And groundwater recharge from the unsaturated zone and from deeper layers, I think it should best be separated, be analyzed separately, because it has large differences. Groundwater recharge can be reduced using other land use types to increase your evapotranspiration. I understood yesterday or the day before that several activities are already going on into that field. And crop rotations may increase nitrate leaching. Platy soil structures I already mentioned. Then future developments, I think here is a tool which you may use for many other purposes, such like use it for future seasonal climate change. There's another European project which the results may be used. And of course, I find it hard to find observations of groundwater levels at a larger scale. It would be nice to have more data and more access to these data. And then it's a complex system, but I think it requires complex tools to gain insight into system behavior. And last sheet, I mean, all tools and things we developed, they're public and gratis, so to say, for free. And I hope we can intensify and continue the nice cooperation we had between Argentina and the Netherlands. Thank you for your attention. Well, different stories, but okay. It's good, huh? Yeah, that's what I liked very much. Took a lot of time, but it was very nice. About 3-4 years ago. So yeah, it was very...
Muy bien, ahora sí. Hicimos este minuto de silencio para que piensen las preguntas.
We took a minute to be silent so you can think of the questions.
La pregunta que voy entregando, pero arrancando con
This is a question for Pablo. What's the most convenient investment that we can do? Where we can or how much we can invest in a federal country? We understand that it is a federal country, but the spirit behind it is a unitary spirit. So how can we capitalize the fact that we are federal to be effective? This is a very profound question because resources are generally scarce. I think that we all know and understand Argentina has an infrastructure deficit in general. So it's not something that can be reverted in the short term. This is a long-term process. Regarding adaptation works, we need to bear in mind that we believe that Argentina has to be a federal country. This is what is written in the Constitution, but we know that for many years it didn't work that way. In practice, many decisions were centralized. So the government is now trying to give back resources to the provinces. The government is returning progressively part of the federal co-participation so that it is directly managed by the provinces. Our counteraction is try to consider how much provinces invest and how much the national government invests. So we establish a criteria for investment amounts. Our ratio is 30 and 70. This means that the national government should invest 70% and the provinces should invest 30%. This is to promote the capacity in the provinces, the capacity to be a government that also manages investments and not only the checking account or the regular expenditure. The second criteria is that the national government should participate in largest investments. This is a political criteria. And another political criteria is to build smaller works or smaller projects in Buenos Aires. So the works that can be completed by the local municipal government should be completed by them. And the same could be said about works in the provincial jurisdictions. In some cases, there is a need for investment in the provinces that goes beyond the investment capacity of the provinces. In that case, the help of the national government would be needed. The Constitution gives the national government a sort of power on the decision-making processes because it is written in a way that we can interpret that the national government sort of oversees and has a more comprehensive view of how things are. And so some decisions are ultimately taken by the government. And something that is true and should also bear in mind that not all the provincial governments belong to the same party of the national government. It happened in previous governments that as the province of Córdoba was from another party, that the national government, no money was sent to Córdoba. What we are trying to do is to start with a period of independence where it has nothing to do what is the party in the national government and what is the party in the provincial governments. The city of Córdoba has 1,300,000 inhabitants, and it does not have a proper sewage infrastructure. Why half of the Argentinians don't have sewage pipes? Because sewage infrastructure is something that is not evident. It's something that people don't see. And so it makes it, I mean, from the political point of view, is not a good advertising because nobody sees. And the same happens with water treatment plants. They are far away from the cities, and so people don't see them. Our criteria is also considering that adaptation does not include only building works. It also has to do with having capacity in the government. We need to have a government that has real authority, regardless of the political parties or of the administration in force. We need to face the problems of climate change, and we all know that climate change will have a negative impact. That's why we are trying to change our criteria when deciding where investments are used for or where investments should go. And we also another goal that we have is that we want Argentina to be transparent in resources allotment. All the terms of the bidding terms of any work that is conducted should be published online, so everybody knows exactly what is being built and who submits a proposal to the tenders. And so everybody knows, for example, that the work that I was talking today about the canal should be completed in 4 years' time. No matter if this government continues or not, it has to be a policy of state. I have a question for Hughes. We should also bear in mind, we should take as a criteria the taxing system so that the provinces can have resources available to make those decisions. We are going to come back. Hughes. Something I didn't understand very clearly, but the result of the analysis of your model, you saw that with the crop rotation compared with soybean, it increased the risk of leaching.
The leaching rates occurs especially when you switch to other crops.
En realidad, el lixiviado ocurre cuando se pasa a otro cultivo. Por lo tanto, hay que equilibrar por ese nitrógeno que se fue por el lixiviado. No es un riesgo. Yo no digo que eso va a ocurrir. Tenemos que tenerlo en cuenta. Es el balance nutritivo, el equilibrio de nutrientes. I understand that vision. If you have to add crops that need nitrogen, and increasing the rotation intensity, you avoid leaching. It's a very good clarification. In this interaction, public-private interaction, public-public interaction between the university and the INTA from one country to another country, and taking into account the comment Pablo made, how can we speed up that collaboration? And this question is for both of you. how we can speed up the collaboration, considering what already has been done with the help of the Netherlands to Argentina. No sé qué pasa en Argentina, pero en los Países Bajos, sin duda, las empresas privadas también quieren hacer las cosas de manera sostenible. Esto es algo que se ha incorporado y en los Países Bajos se ha hecho de muchas maneras hasta ahora. Yo creo que los objetivos de sostenibilidad, como los que imponen las Naciones Unidas, son un buen impulso para poder unir justamente los proyectos con combinación público-privada. In the world, there are many sources available of financing for collaborative projects. This has to be the result of the joint work if the interests are in line. We were talking with Maria José today about one of the possibilities that we are going to explore. We are going to consider international funds to create a simulation model for the central area of Argentina, a hydraulic productive model taking part of what Hughes presented today. What we could do here is to bring this together and create a consortium. Also, a PRESID can be part of this consortium. We need to try models that include private companies that have real interest in the short term in the markets. What happens to us, there is a huge talent capacity organizations, but we don't have this exercise of going out to the market and taking into account results that have been obtained somewhere else. This is an exercise that companies do by nature, so we need to increase the ecosystem and we need to generate that consortium, that possibility to work together. APRESID is an example, and ACREA is another example, but we need to do this at a more international level. Argentina entered into this agreement with the Netherlands. So what we achieved was funding or financing of the FMO, which is the Bank of the Netherlands, with the loan was 2 billion euros. This is a huge amount of money, but this won't be realized only by governments or governments alone and the research institutes alone. We need the dynamics, we need the contribution and the willingness of the private sector to contribute with funds. You are sort of giving, with what you have just said, you are opening up or giving continuity to the next panel that we are having. We will talk about APRESID activity thanks to the interaction of provincial governments and different organizations concerned with the topic of water, private companies, growers, and international collaboration as the one we have received from the Wageningen University. So these are clear examples of the need to have private-public combination. As we were talking at the beginning of this panel, the challenge of climate change is something that will grow further. So and we need to have an attitude that we should prevent that from happening. Thank you, Cruz, for your patience, Pablo, for your presence. I apologize if there are some questions couldn't be asked because technology didn't work. A round of applause for them.